Welcome to LNP Noble Simulator. Today we are going to discuss some of the MEP basics part 11. If you have missed part 1 to 10, please subscribe to our channel. In our channel we had created a playlist MEP basics part 1 to 12 English, so that whatever thing that you have missed you can check into it. We are in our discussions we might be using so many symbols, acronyms and short forms. If you have any sort of doubt, kindly please refer to this part, so it will be useful to get clarified. So what are the things that we are going to discuss today in this part? So how a scheduling components is very much important. What are the parameters that we are going to consider? How we can do scheduling, okay? And what are the controllers and the control loop points of a HVAC plant, okay? How a router control and we can facilitate traffic between the different networks. How architectural layout looks like. And most importantly, we are going to learn the hierarchy of BMS configuration, okay? How a BMS configuration looks like, how a general purpose controller diagram looks like, how VAV controller layout looks like, and what are the superimposing control requirements from other systems. So as you can have a schedule components, okay, for the temperature, okay, you can have a start date and a stop date, okay. If you're going for a week, okay, from which date it should start and from which day it should stop. If you're going for a monthly view, you should know which month it should start, which month it should stop, okay. In between you can have a times also. If you are having exceptional dates or holidays, you can update them in the schedules also. In that you can provide a date, recurring date and day of the weeks as well, okay. So each control program has one schedule, okay. The schedule could be the same for all the control programs or unique for each. So it is up to us to create a schedule for each and every program that we are planning, okay. If you have a common calendar block, it will be typical and common program for everything, and most importantly even for the control loops and start and stop of a control loop also you can schedule, okay. Next, if you are going for a controller points, okay, as we told earlier, okay, normally either it is a BMS controller or a DDC controller or most importantly a PLC controller, okay. It has a CPU, it has a memory, it needs a power supply to run, it has a memory, it can be a random memory or read-only memories as well, okay. And most importantly, okay, with the LAN network we are establishing input and output connections with the controllers. So the controller has the capability to do so many mathematical operations, addition, subtraction, multiplication, division, logical operations, mathematical operations, pseudo points, set points, like that. So many operations a controller can make, okay. And most importantly, not only with the controller, we will be connecting so many digital inputs in it. It can be a status or an alarm, bypass, pulse meter, anything, okay. And also we are providing some command through the controller. It can be digital command, it can be a starter, relay, solenoid valve, damper actuators, valve actuators, it can be anything, okay. And if you're getting as a analog input module, it can be a temperature sensor, it can be a humidity sensor, it can be a pressure sensor also. If you're going for analog output, it can be a damper actuator, valve actuator and variable frequency drives. So if you're going for a control loop, we have a reset and recovery option, we have a set point option, okay. Most importantly, the set point will come for the occupancy sensors, temperature sensors also. In order to initiate any sort of input, in order to initiate a loop, there needs a set point. It can be digital set points also, or in certain places if you want to limit something, some values, it can be analog input signals as well. So as a control output, as a control parameter, okay, it can be a PID loop, okay. We can produce an analog output, or in certain places you need only digital output also you can produce. So this is the entire concept of a control loop. So we will have the set point. Based on the set points, we have some control parameters and we will have a sequences, and in certain places if there occurs any issues also we need to raise alarms also, okay. Even for the override as well as the if any mishappenings which is happening in the outside also you need to raise up an alarm, okay. So this is a simple common duct temperature sensor. As you can see here, we have a supply line, we have a supply duct, okay. The temperature is around 27 degrees Celsius. So if you want to cool down it, you need a help of cooling valves. We have a VAV boxes, we are controlling the VAV boxes, damper actuators with the help of a DDC controllers. For each and every room we have a temperature sensors, okay. This is a simple graphical view, okay, and this is the plant status. As you can see here, we have a heating and cooling provisions, okay. We are enabling them and we are controlling the valve actuators wherever required, okay, and we are measuring the temperatures inside the individual ducts. and we are also measuring the temperature outside as well. So this is as we saw earlier, this is a heat recovery system which has a water to air pumps, okay, in a closed loop. Okay, we have a supply piping as well as a return pipings also. So when you get into the routers, okay, we will have operator workstation. From there we will have a different routers. From in the router we have a sub networks also. Okay, so normally the traffic is handled like this only. We will have a main operator workstation. Okay, we will have a servers again, and then only we will have operator workstation. From there we will have a sub routers where all the main controllers will be connected. Next to the main controllers, next to the master controllers, we will have a slave control networks. And if you have an extended network, okay, even with the help of internet world, you can access all the routers from any locations. It can be a modem. Okay, so based on the gateway that we are going to use, so based on different manufacturers, the model might differ, but most importantly, everything will have a modem and a operator workstation. From if you have an internet, you can through the internet world you can access them from anywhere, any places. So as you can see, this is the architectural view. Most importantly, we'll have a server, and in order to access, you have an operator workstation. In the operator workstation, through the graphics, you will be monitoring each and everything. Okay, if you want any sort of printers also will be connected with that operator workstation, you can take the printouts from there. And in the remote location, in the fields, we will have a DDC controllers. Okay, and apart from it, we also have an additional controller to control the VAV box controllers. So if you are going for a hierarchical BMS configuration level, okay, most importantly, we will have a management level processors. It can be mini computers or it can be a servers. Okay, normally operator level work controllers we will have, so it will be in the other category. And third, next to it we will have a controllers level, master controllers will be there. Okay, so it will be getting connected with so many sensors and the actuators. And also we will have other category where you will have a slave controllers. Okay, in that one only input and output modules will, CPU will not be there. CPU will be only in the master controller. From the master controller, the command is being provided, or the controlling or the entire input and output are getting connected with the master controllers. So this is a typical hierarchy of a BMS configuration. So in this also we are using so many logics. Okay, we have a distributed intelligent network or a peer-to-peer networks connections as well. This is a typical general controller diagram. As you can see here, we have a supply lane, we have a supply fan, we have a cooling coil, we have a temperature sensor, we have a humidity sensor. So all the sensor input we are connecting to the controllers. Okay, these are the input signals. Okay, and most importantly, all these valve actuators, okay, chill water valve actuators, damper actuators, all these things will come under the category of the analog output signals, which are being commanded by these DDC controllers. And even exhaust fans also. In the fan also we are monitoring so many fan status, that is on off status, trip status, fault status, each and everything we will be controlling it. Okay, so this is a VAV controller layout. As you can see here, this is a terminal unit. Okay, we are having a VAV actuators. Okay, so it is the work of the actuator to open and close the dampers. Okay, we also have the temperature sensors to measure the temperature. You also have the set point adjustments in the temperature sensor. Based on that set point, so it will command the valve actuators, especially the damper actuators, to operate. Okay, so this is the room thermostat diagram. As you can see here, we have a 4 to 20 milliamps output command for the modulating, especially if even it is for heating or cooling, we can command using the 4 to 20 milliamps output from the controllers. So we have the sensors to monitor the humidity, and we also have the sensor to monitor the motion, that is the occupancy. Okay, and most importantly, in order to control the fan relays, we are providing the transformers and power supplies. Okay, in order to measure the outdoor air, we are having the outdoor air sensors also. Through the loan network, normally we used to establish with the other equipments as well. So for heating, if you require, you can have a separate transformers, and for cooling purpose also you can have a separate temperature. So when you get into the controllers like this, you need to superimpose or with the so many other systems. Say for example, lighting control system and access control system normally integrated. Okay, if there occurs any sort of issues, the light should on. And also, if there occurs any sort of fire, the heat ventilation air conditioning system should get shut down. Okay, if there occurs any sort of access control issues, or if there occurs any sort of fire alarm issues, then the access control system should open. Like this, these are all interlinked system. Even the chill waters, okay, in the chill water system has a access control, has an interlock with the access control system. Okay, and most importantly, even with the fire alarm systems also, it has interlocks. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have brought the contact list here. We, LNP Renewable System Limited, we are providing PLC programming training for Siemens, Allen Brodie and Delta PLCs. We, as a LNP Renewable System Limited, if you had a plan to work in GCC countries like Qatar, Oman, Saudi, Dubai, there are so many job opportunities for building management system, building automation system, access control system basics, electric vehicle technology basics, and especially if you want to learn the MEP basics also, you can contact us. We are providing contact details here. So we, and if you have had a place where EB power is not available, there if you want to establish a solar DC light system, then you can contact us. We are providing our contact details here. And if you might have an agriculture farms, if you want to protect your crops from the wild animals, instead of going for normal fencing, you can use a solar fencing. Okay, we are providing solar fencing as a kit. We are also providing solar on-grid, off-grid, hybrid applications, solar street tilt, solar pump services, design, installation, testing, commissioning, consultancy and training supports also. Thank you so much.